All right, what's up, you guys? Welcome to our first video of the quarter. We're going to be doing a quick refresher on polarity. So maybe you took chem a long time ago, maybe you took it recently. We're just going to go over the important points that are going to relate to bio in this quarter. So quickly talking about stuff that's polar and stuff that is non-polar. So a straight up definition would be for polar would be there's a large difference in electronegativity between two atoms in a bond. Right, so the example we're going to say, let's talk about the carbon-oxygen bond. Right, think about this bond, right? It's made of electrons. If oxygen is super electronegative, those electrons are going to want to hang out around the oxygen. So if this bond was a cloud of electrons, all the electrons would be hanging out over here by the oxygen. You guys know electrons have a negative charge, right? So that means this area by the oxygen is going to have a partial negative. There's going to be an equal and opposite partial positive on the carbon. So you don't really need to know about electronegativity for this class. You don't need to look at the periodic table and know like the exact values for electronegativity, but do know the main point that polar bonds are going to have one partial negative end, one partial positive end. Right, let's compare that to nonpolar bond where there is little to no difference in electronegativity. Between the atoms and the bonds. The example we're going to talk about is carbon and hydrogen, right? Where if the electrons in the bond were like a cloud around them, they would be distributed equally, right? There's no difference in electronegativity. They're going to share those electrons equally. So that means that there's no one side that's more positive or more negative than the other, just simply nonpolar. Right, so I'm going to get rid of the clouds. What you need to know for this class is you need to be able to identify stuff that's polar and nonpolar really quickly. Right, it's kind of easier to start with polar stuff. So examples of nonpolar bonds are the carbon and hydrogen bonds and the carbon and carbon bonds. Right, so you want to look for those. You can also see those represented in line formation, where when you see something like this, these lines are just carbons and they're attached to a bunch of hydrogens. So when you see line notation like this, know that this means it's nonpolar. When we're looking for polar bonds, some common polar bonds in bio are the carbon-oxygen, nitrogen-hydrogen, oxygen-hydrogens. Basically anything that is not these guys. One of the nice things about bio is we only deal with a couple atoms, so you don't need to memorize the whole periodic table, right? We're going to be dealing with only a couple of atoms here. Right, so your job in this class is to look out for these kinds of bonds, know that they're nonpolar, and look out for these kinds of bonds and know that they're polar. Another note is that like attracts like. So polar things are going to attract other polar things, right? So attracted to other polar things, right? Like attracts like. Same deal goes for nonpolar. So nonpolar things are going to be attracted to other nonpolar things. So both sides follow the rule of like attracts like. This is really important when we talk about bio because we are 70% water, right? Water is a huge important deal in bio. We're going to talk about it a lot. Right, so when you look at water, this molecule, can you tell, is this molecule polar or is this molecule nonpolar? Right, water is definitely polar, right? It has those oxygen-hydrogen bonds. So polar things are going to be attracted to water. So we're going to call them hydrophilic, right? Because they love water. On the other hand, nonpolar things are going to be repelled from water. It's like oil, they don't mix, right? So these guys are going to be hydrophobic. Cool. Now that we've gone over the basics, this is basically what you need to know. Don't worry too much about electronegativity. We just had to put that in there to make sure that you got the point. Go ahead and pause and try this question again if this video helped you. Okay, welcome back. Hopefully you paused, try this on your own. So one thing to notice about all these compounds is this region, right? We talked about its line notation, it's nonpolar. However, we have the OH group, so it's polar, right? All of these molecules have polar and nonpolar regions, and that's totally valid, right? Some things that we see in bio are going to have polar and nonpolar parts to them. So when we want to know which one is the most polar, we're looking at the one that has the largest ratio of polar to nonpolar. Right, so we're talking about this guy here, where yes, they all have the polar OH group, yes. However, this one has the smallest nonpolar region, right? So we're going to call that one the most polar. Then we're talking about which is the least likely to be soluble in water. If it's not likely to be soluble in water, hopefully we're on the same page, that means it's nonpolar. So this second question is just a way of asking us which one is the most nonpolar, and that would be this guy with the really long nonpolar chain. All right, cool. I hope that this video kind of helped get us on the same page so we can move forward in MCDB 1A.